And welcome back, and it's the 25th of Jan and it's the Further Maths 5 a day. Let's go with the first question. Okay, so we have a piecewise function here, and it basically tells me there's three different functions, but they only work between certain different domains, if you like, or certain different inputs. Let's start with the middle one, and because I think that's going to give us a bit of a frame of reference. So between x is -1 and 1, I should have the line y equals 2. So if I zoom in, I can see -1 is here and 1 against 2 is here. So let's join those up. Now, my guess is, I haven't done these questions, but my guess is they're all going to join off the same point. So it'll be nice. It won't be a smooth graph, but it'll be a continuous graph. Then if we look at the first one, so we've got x plus 3 at the top, and that's between -2 and 1. That's a linear function, so therefore if I put -2 in, I get -2 plus 3 is 1. And if I put -1 in, -1 plus 3 is 2. And there's my 2 value. So -2 goes against 1, which is down here. And so therefore I can join these up, and it's going to look something like that. This bottom function is 2x, so the gradient is going to be 2. So if I put 1 in, I get 2. So again, it's going to join up. And if I put 4 in, I'm going to get 8. So that's going to give me, well, let's plot the point 4, 8, which is up here. And I've got a gradient of 2. So let's go across 1. Oops, sorry, pen's not working. Let's try that again. And I'm going to go across 1 up 2, across 1 up 2, across 1 up 2, etc., etc. And I should, and I do hit that line. And that's the first question done. Just so I said it out loud, let's say they didn't connect. Well, the way I'd have to do that is I'd have to do a circle at the end of the point, and then I'd do a filled in circle at the new point, where the filled in represents less than equal to, and the open circle represents less than or a strict inequality. But that's not the case in this question. So first question, not too bad. Next question. A line passing through -3, -6, and g -5g has a gradient of 3, find g. Oh, it's going to have quite a lot of negatives in it, isn't it? Okay, let's set it up. So I know to get from -5 to 6, I'm going to go, well, let's do it the other way around. So I'm going to do -6 minus -5g is my rise, and my run. So I have to do -6, I have to do the equivalent x1. So it's going to be -3 minus g is equal to -3. Okay, let's tidy that numerator up. So that's going to give me, well, minus is plus 5g. So that's going to be 5g minus 6 over -3 minus g is equal to -3. And let's multiply through by the denominator. And that's going to give me 5g minus 6 is equal to, now -3 times -3 is +9, and -3 times 3g is +3g. And we've just got a straight linear equation now. So let's take away 2g from both 3g from both sides, which gives me 2g. And let's add 6 to both sides, which gives me 15. And that means g is equal to 15 over 2. Actually, not a terrible question. Nice little sort of early paper sort of question. What have we got next? Okay, final question today. Wow, a lot going on here. It tells me a curve has 2 stationary points. Now, generally, the number of stationary points is 1 less than the order of the function you're looking at. Not always, but vast majority of the time. So 2 stationary points means I have a cubic, which means it's either going to do that or it's going to do that. So I'm looking for where dy dx is 0, and I can see it's 0 at x equals 3 and at x equals 7. And then it also gives me some values here of f of 3 and f of 7. So let's just quickly knock up some axes. So here's my axis here. And let's put 3 against. Now, you don't have to be precise, but it's helpful to be roughly correct. So 3 goes against 8, so that's going to represent my scale. And 7, which is somewhere around here, goes against 2. So I've got a point here and a point here. And then it also tells me that f of 0 is 1, so I also know that it goes to the point here of 1. So I already know which one it's going to be. I know it's going to have to be this one here, because that's the only way I can sort of have a maximum and a minimum it can fit in. Let's just check what the rest of this means. Actually, let's draw it in and let's talk about what this means. So I know I'm going to come up. I know this is either a maximum or minimum. Well, it can only be a maximum, technically a local maximum. Maximum or minimum, again, it can only be a local minimum, and that must be my graph. Couple of things that are going to help me out as well, because I've missed out a bit of the question. It also says dy dx is greater than 0 for x less than 3. Well, that's true, isn't it? Because you can see my gradient here is positive because I'm going up. It says between 3 and 7, my gradient is less than 0. And that's also true, because you can see I'm going down, which is good. And you can see here my gradient above 7 is greater than 0. And that's also true because I'm going up. So actually this question is giving me too much information in some ways, but equally it's a really nice sort of understanding question. Usual thing, as ever, quite a nice little mix of questions today. Do like, subscribe, comments below. The channel is slowly growing, but your help would be much appreciated. Thanks all.